So welcome everyone to the Sleep Tech workshop with my friend and fellow TED resident colleague, Dan Gartenberg. You know, it used to be if you were a doctor and you went to a cocktail party, people would take you aside and say, "Doctor, I've got this pain in my arm over here. Can you tell me what to do?" I have to believe, Dan, that when you go to a cocktail party and tell people you're a sleep doctor, that the Dr. Snooze is the hit of the party. Like, do people bring you aside and say, my bed, or I'm not sure about my mattress, or I need
yeah.
Yeah.
It can be a little annoying, but if I'm already talked out on sleep, but happy to usually help.
All right. So here's what we're going to do today. We have half an hour. I'm going to jump off here. Dan's got a presentation. He's going to walk you through exactly where things are going with his technology. At the same time, there's a chat box available on the screen. He's said he's open to this being interactive. So if as he says something you don't understand it, or it confuses you, or you have a question, just throw it in the chat. And when we have a place where we can break, I will jump in. All right. So I'm going to hide, and Dan, take it away.
Sounds good. And thank you for taking an interest in my research focus for the past 15 years, which is how can we enhance and optimize people's sleep so that the 30% of our lives spent sleeping is just a little bit better. And so that's sort of the goal that's been driving my research on this topic for quite some time. I initially was a researcher at Naval Research Labs and Air Force Research Labs, trying to use AI to predict actually when pilots got fatigued to try to prevent them from crashing, a $30 million plane or something. And then I sort of stumbled on some research findings on new ways of enhancing people's sleep. And I'm going to get to that towards the end of the conversation. But first, before we get into that, let's just have a sort of a sleep science overview, make sure we're on the same page of what sleep is actually made of, and how it's typically measured in the field and standard clinical practice today. So there's a couple ways that we measure sleep, and I've tried almost all of these gadgets here. The way that we think about it is there's polysomnography, which is a montage of electrodes across the scalp. You have one on your chin usually, and you have an EKG. You're basically measuring different physiological aspects of the person in order to predict the sleep stage. And generally speaking, the Americans say that there are 3 sleep stages. The Europeans have 4 sleep stages. This is partly because of the fact that, physiological processes are sometimes not easily separated into these clean buckets. And some researchers even claim when you do a machine learning analysis, there might actually be as many as 19 stages. So it's quite complicated, and we still don't understand all the nuances of it. It was really only the stages were really only discovered, in the 1940s, when we first connected people to electrodes and discovered a lot of activity in people while they're in dream state. So originally it was just non-REM sleep and REM sleep. And then they eventually made more stages, breaking up the non-REM cycles into deep and light, essentially. And you have these cycles throughout the night: light sleep, deep sleep, light sleep, REM, light sleep, deep sleep, light sleep, REM. Throughout the night, you gradually get more REM sleep. You have more deep sleep in the beginning of the night. And the gold standard way that we measure this is with these electrodes. And actually, a technician will manually score these 30-second chunks of time. And so if you were to go to a sleep clinic, there'd actually be a trained polysomnography technologist that would look over your brain waves and be like, this is deep sleep, this is light sleep, this is arousal, maybe you have sleep apnea. That's the main reason you go to get this done to begin with. If they think you might have sleep apnea or another sleep disorder like narcolepsy. So that's the gold standard way, but even the Cronbach's alpha, the agreement between the scorers, is pretty good, but it's not 100%. So even the electrodes, there's a little bit of inaccuracy because there's a human aspect to it, and there's AI to automatically do this and whatnot too. Now, there's another set of devices that we call wearables, and we have the Oura Ring. I in particular use the Apple Watch, and we have an algorithm on that. And my company, SleepSpace, has developed algorithms on the Apple Watch. I think we have almost the most accurate one. We're really accurate for sleep wake, which actually some of these wearables are not even that good at. There's probably like an upper threshold of about 95% accuracy for detecting sleep wake, and about 70% accuracy for detecting the sleep stages on these wearable devices like the Ring and the watch. Then there's another set of devices, because a lot of people don't even want to wear anything while they sleep, around 50% of people. And you have these nearables that use the microphone and stuff like this to get some kind of proxy of people's sleep. But they really can't get sleep stages that accurately. And then actually the doctor doesn't even care that much about any of this. The certain types of doctor, the psychologist doesn't care. They actually care about the subjective experience of people's sleep in these standard sleep diaries. That's actually the most important thing, the phenomenological experience of people's sleep. My belief is that, there's trade-offs in all of these, and there's a time and place where you might want to use each of these measures. It basically depends on your problem. So here's me I'm like a crazy mad scientist person. I've used almost every single one of these wearables, went to a sleep lab, have a really good sense of how much deep sleep I actually get and stuff like this. And I've seen for myself that sometimes things like Oura Ring can underpredict deep sleep, for example. And there's actually a new concept in sleep called orthosomnia, which is when the devices are wrong. It actually creates more anxiety from the person and gives them and actually can result in insomnia. And they call this orthosomnia. But so you have to take some of these devices with a grain of salt, and I'm going to try to help you understand how to do that. Basically, the wearables are good for giving relative truth, but they can be quite off in absolute truth, because basically the algorithms are made for a general population. But if you're an older individual or a child, or maybe have a sleep disorder, oftentimes the algorithms break down and can be pretty inaccurate. So this is the gold standard. As you might imagine, this act of measuring sleep can oftentimes impact the thing that you're measuring in sort of like a Hawthorne effect kind of thing. And a lot of people that go to these sleep labs to get checked out for things like sleep apnea or narcolepsy will be like, how can you possibly measure my sleep? I barely had a good night's sleep in the sleep lab connected to all these devices. The answer is they just need a little chunk of sleep. You only really need to be asleep for a small amount of time to see if there's something physiologically going on with something like sleep apnea. Basically, you oftentimes go to a sleep lab because you're really tired during the day, yet you're getting enough sleep. And they'll find maybe something wrong with your sleep quality. If you have severe sleep apnea, you can have as many as 100 awakenings per hour. That's a severe case, without having any conscious awareness of it at all. We call this cortical arousals. And there's a bunch of there's the stages, but there's a bunch of other processes in sleep, like K complexes, which are these spikes that happen that I'll show you a little bit more in sleep spindles. And yeah, this is what I mentioned before. There's not even there's pretty high agreement amongst the scorers, but nothing is perfect. But this is the closest thing that we have right now to getting an accurate measure of your sleep. And when they're looking at your sleep, they're not even just looking at the stages, but these micro events that can happen in your sleep. And really what's going on with our brains here is our brains, and there's something in sleep called the synaptic homeostasis hypothesis, where our brains are basically processing the fabric of our reality while we're sleeping. And there's this K complex and a sleep spindle that basically is converting the things that happen to you during the day into long-term memory. And how it works is basically during the day, your neural activation overall increases. Some of that information that the neural activation is increasing for is relevant to your survival and your well-being and your goals. Other information is not. We don't want to store all this irrelevant information. So basically, during deep sleep, you have this down regulation of all your neural processes, such that the relevant things to your survival go to the top. And then during REM, you integrate and process those things into long-term memory. And a lot of these K complexes are very similar to delta waves. So these long burst wavelengths that's very different from your waking life. And you'll get a series of these things that look like K complexes. It's quite beautiful on the EEG when someone's in deep sleep. And that's when all of your neurons are basically downscaling. And there's these, neural regions that I'm a cognitive psychologist, not a neuroscientist, so I have an understanding of the process, not some of the neural structures quite as well, but you can see some of the details on the left part of the screen here. And our research is trying to explore how we can entrain these K complexes or delta waves, basically. But these are also related to, like, if you have more sleep spindles, you're less likely to be disrupted if you hear a sound in your external environment. So these are sort of designed to keep you asleep and to sort of translate information to they're generated from the frontal lobe, these K complexes, and then they occur throughout the cortex. It's sort of like this transcription process that's going on. It's quite complicated. So that's like the deep science of the objective way of measuring sleep and what everything's doing here. What's going on here? And so this is actually another way that psychologists often measure sleep. It's basically just a paper pencil sleep diary. And what they're trying to do is figure out if you're spending a lot of time awake in bed. So this is typically used for insomnia. And the treatment for insomnia, it's so sad, is often sleeping pills. Yet the recommended treatment of the medical community is cognitive behavioral therapy for insomnia, which is some behavioral interventions that happen over a 6-week period. And that's what we use the diary for. And we actually digitize this diary to try to help clinicians organize the information so it's just not all in Excel or paper pencil. And so our goal as a lab, and I work with a collaborator at Penn State, we get this funding from the National Institute of Health to try to understand how we can actually use these devices, not just to track sleep, but to augment sleep. So we published this paper and ran this crazy study where we brought people into a sleep lab, connected them to a bunch of wearables, hooked them up to EEG, polysomnography, continuously for 3 to 4 days. And then Margot, the postdoc that we work with on the right here, systematically played sounds to people while they slept. So she would look at their brain waves, determine what stage of sleep they were in, and then basically gradually creep up this sound right below the level that would awaken them. So I think about it, and Orfeo, my mentor, describes it as like a tightrope walk, where if you basically poke too hard, you wake the person up, because you want to be somewhat alert to your environment while you're sleeping, so a predator doesn't eat you, essentially. If you don't poke hard enough with something like a sound, then the brain won't elicit a reaction. So what some researchers showed, not our lab, but another lab, is that you could basically entrain these delta waves by pulsing using sounds. It was originally using transcranial direct current stimulation, basically like zapping at a certain pulse in the brain. But they showed that your auditory cortex, picks up sounds in a similar way. And we showed in an EEG, basically, we played the sounds at these bursts here that replicated the delta wave. And then this is an actual readout from polysomnography. You see the different channels here. This is actually an EOG. If they're in REM, their eyes would be like darting all over the screen, and you'd see that they're not in REM here. But you'll see we play the sound. This is the auditory channel. We play the sounds here, and we're eliciting these brain waves. We're basically playing it at the same pulse rate as the delta waves to try to elicit these regenerative brain waves that are thought to be related to human growth hormone, conversion to Alzheimer's disease, which is what I study, learning. It's just you want more deep sleep, basically. REM is also good. And so this is a 16-channel electrode. You can actually get, if you have enough channels, you can actually understand location that these brain waves are occurring in and stuff like this. The question that we have in our lab is, are these regenerative brain waves, or are they sort of an artifact? So one thing with the K complex, it was discovered because someone knocked on a door and it elicited this brain waves. They can be elicited through basically a response to stimulation, to a stimulus. And so we want to not only show that we can produce these brain waves, which we demonstrated in a peer-reviewed publication, but we can actually improve cognition the next day and maybe increase human growth hormone and stuff like this. So we haven't exactly demonstrated. We showed the brain waves, but we haven't been convinced by the cognitive tasks yet. So we're sort of still working on really validating that we can enhance people's sleep. We do know for sure that by simply blocking out noises in your environment adaptively, that this is a way that we can enhance people's sleep. And so that is something that we do with our software. But the other thing, when we conduct scientific research, usually there's reach hypotheses and then things that we sort of know will work. Since we had all these data sets from the Oura Ring, from the Apple Watch, we could make a really sophisticated algorithm. So this is like a ROC curve that, signal detection theory that some people might be familiar with. Basically, if the curve is in the upper left corner, that means it's more accurate. So this line is more accurate than the green line here, is how to interpret this. And we compared the ECG data. So this is basically, ECG is as accurate as you're going to get for heart rate as you possibly can. And we compared that from the polysomnography, and we had a clinical watch thing too, with the Apple Watch and the Oura Ring. And we were able to get really good fits, basically. Here's some data that another researcher showed on the accuracy of an Oura Ring. As you see, it can be quite inaccurate. 65% accurate for light sleep, 51% for deep, 61% for REM. Our new algorithm, I think we're hitting around 70% accuracy, and we're publishing this algorithm. And unlike a lot of these other companies, we're opening up our algorithm to researchers, to clinicians. We're not black boxing it. So all these companies black box their sleep detection algorithm because they think it's like what they have is, super proprietary and they don't want to share it. We're actually opening it up because we see the future of sleep in not simple sleep detection. I think that's everyday technology. But actually in sleep enhancement. So we're actually going to open up our algorithm that's going to be the most accurate one on the market that'll work with almost any wearable. And clinicians can actually see the margin of error so they can make heads or tails of what's going on with the person. Oftentimes, when I interpret, for example, my Oura data, I'll interpret it in terms of relative truth to myself. So if it says I'm worse, if I'm comparing it to myself from one night to another, it might say I'm worse or better, but I won't think of it as the absolute truth to how much deep sleep I actually got, if that makes sense. Um,
So,
and
so we have an audience question from Abram. He's asking, how does SleepSpace compare to sleep tracking on the Apple Watch or Aura or Whoop? I didn't know what Whoop was.
Yeah, Whoop. So our new algorithm, I mean, I'm running a version of the software right now where I literally see Apple Watch data alongside my Aura algorithm. And our next version of the software, we literally see all the data stacked up alongside of each other. Because I'll sometimes track myself with the Apple Watch, and I'll run my algorithm on the Apple Watch, and then I'll run the Apple Watch algorithm. Our algorithm, well, first off, Apple Watch doesn't measure sleep stage because for them to be wrong would be really bad for their branding. So like they're too worried about the inaccuracy of this to actually give you the sleep stage information. We will give you that information, and we'll also measure basically these brief awakenings that the standard Apple Watch will not detect. So they're sort of giving a more coarse analysis of your sleep that maps on more to your subjective feeling of your sleep and not necessarily these brief awakenings that you might not be consciously aware of. And also they won't give you the sleep quality information.
All right, so I have one. There are some notorious CEOs who are quite proud of how little sleep they operate on. Uh, is that just nonsense? Is that completely untrue? I mean, are there people that are more productive because they sleep 4 hours a night?
Yeah, so basically like 99.99% of people cannot sleep 5 hours a night on a regular basis. So the consensus in the clinical community, there's a consensus report from like 10 top doctors in sleep that adults need 7 to 9 hours on a regular basis. And so that's 7 to 9 hours. Keep in mind that's sleep, not time in bed. So I have like a blog post that I wrote, like 8.5 hours is the new 8 hours of sleep. That's because to get 8 hours, which like, you know, at least 40% of the people in the population need like 8 hours every night. But to get that amount, you usually need closer to 8.5. So like, for example, I can actually pull up my data last night on my tracker. So for one of these nights, for example, I was in bed. This is pretty good. So I was in bed for 8 hours and 52 minutes, and I got 8 hours of sleep. Actually, so the Apple Watch is saying something different. So the Apple Watch says I was in bed 8 hours, 24 minutes, and I got 7.5 hours of sleep. And that's around 89% sleep efficiency, which is pretty good. My algorithm actually said I was in bed 8 hours, 50 minutes, and I got 7 hours and 9 minutes of sleep, which is actually not that good sleep efficiency for me. I
So,
was a little stressed.
so
Yeah.
Dr. Snooze,
Yes. Sorry.
what is where do you come down on napping?
So this is the complicated thing about all this, which is, and I'm going to pull up, I have actually 2 decks here.
It's all right. We've only got about a minute left. We
Oh,
got
okay.
like 2 minutes left, 3 minutes left.
Oh, really? Okay.
Yeah.
So with napping, if you have a problem falling asleep and staying asleep, basically you should not nap. If you're an insomniac, you should not nap. Otherwise, it's useful to nap in order to basically during your circadian dip, you can get like a second burst of energy. And I was most efficient during a period of my life when I was like sleeping 7 hours, like a little less than I needed, and then taking like an afternoon nap. I mean, that can be a very healthy thing. But this is the issue with sleep and where a lot of the wearables and technology goes wrong. I would recommend a nap to an optimizer, an executive, for example. But if you have problems falling asleep and staying asleep, basically you should not nap. And then just to speak to the executive again, like I totally get you might have like these work sprints where you get in a manic state basically, and you're like really working and maybe not sleeping. But having the metacognition awareness that that's not a normal way for your body to function, and then to ramp out of that and to get a healthy night of sleep is like really important for your body to successfully recover.
Okay, so let's dig in here a little bit. It turns out we have a few more minutes. Our schedule gave us a little bit more room, which is great. And by the way, listeners, viewers, jump into the chat, make this interactive, ask Dr. Snooze questions. Essentially, this is your opportunity to be at a cocktail party and find out that the guy across the room is a sleep doctor. So you're crazy if you don't ask him questions. By the way, the reason I asked about the nap is because there's a famous moment at the TED residency where we were there all day, and there was a picture that was taken of you napping on the couch, which became somewhat legendary among the TED Res people. Dr. Snooze napping was a classic picture. You know, let me play devil's advocate. Is there a chance that we're opening a Pandora's box that's going to actually be really dangerous? And what I mean by that is, at what point do actual human beings get so much data about the food, their blood sugar, their heart rate, their sleeping, that without being a medical professional, or they simply start diagnosing themselves and kind of like, it's like, I used to own a car, I don't any longer, but I would never open the hood and start fixing it.
Yeah, you're hitting on a really big problem. And by the way, this person who said, how about you can't stay awake? You also shouldn't take a nap if you can't stay awake, is the recommendation. But yeah, this is the essence of the problem. We have all these devices giving all this data. I mean, even I don't know how to interpret it sometimes. And I've spent my life trying to study this. So that's why I think the key, and there's this new concept, orthosomnia, in sleep, that speaks to that exact issue. Basically, the devices are doing more harm than good because people don't know how to interpret their data. That's why, like, the solution here is, there's always a solution. Tech, you can make tech to do anything. And so our solution is, depending on your problem, the clinician can actually allow you to see what data they want you to see. So we have a program. So if you're someone that's really anxious about your data or something, maybe you never even get to see your sleep stages. We're just going to have you focus on your sleep efficiency. So basically our solution is to only allow you to see certain data when it's relevant to the goals that you're trying to attain.
So Abram has another question. He says, entrepreneurs and parents never get 8 hours of sleep. He was most productive on 4 or 5 hours of sleep, but not sure how that affects my long-term health. Long-term health is a great question.
Yeah. So, I mean, honestly, like 4 to 5, I could show you a slide that'll scare you, but I have another slide somewhere that'll scare you. But you're going to increase your likelihood of Alzheimer's disease, which is what we study in particular. There's really strong evidence of that. Hypertension, there's really strong links with that. Diabetes, all cardiometabolic diseases, cancer, there's an association. Basically, every chronic health illness is going to be associated with, and there's also not only associations, there's mechanistic causal mechanisms that we've shown in laboratories using brain scans, blood measures, all this stuff that suggests that your cancer is going to grow more if you're only sleeping 4 to 5 hours a night, stuff like that. And so, I mean, you can do it. And I think a lot of it for me is how you define productive. So, I mean, I think you can, and I do this, like, academics will sometimes for grants and stuff go into a work spree, and I'll like go into like a manic mode almost, and I'll get 4 to 5 hours of sleep maybe, and I'll be pretty productive during that time. I also know exactly what, like, I've already planned when I'm in that state. I'm not doing any like, you can get tunnel vision when you're in that state too. And I'm aware of having the metacognitive awareness of that is really important. Because if you're only getting 4 to 5, sometimes it's hard to think divergently, and you could be productive maybe to some degree, but you can also go into a direction that you shouldn't have gone in and waste a lot of time, because you lose a lot of your global perceptions basically when you're sleeping a healthy amount. So my point is there's a time and a place for it, but it's not something generally to do on a regular basis.
So talk a little bit about the business. So, people are buying lots of devices. I assume some of them are actually, the thing you said about Apple is really interesting, which is they could probably give you more granular responses, but they're worried about liability, brand liability, and maybe financial liability. What made you decide to primarily be a software company as opposed to a device company?
Well, it's actually interesting. So first off, there's so many devices, right? And so to make another device seemed unnecessary. What's really needed is to make sense of all these devices. So we see of ourselves as like an aggregator, a sleep operating system. That being said, I actually did make a device, Steve. I don't think you saw this, but I shared this with you yet. But we have this way of turning your phone into a smart bed, basically, and charging your phone at the same time. And that's what we're validating in a clinical trial. So I did make a device, but it's basically a wraparound for another device. It's a wraparound for your phone to turn your phone into a smart bed. So basically, there's so much tech out there. I'm just trying to leverage what's already existing and help people make sense of it.
Okay, at the risk of seeming not studied up on your space, I don't know what a smart bed is.
So basically, well, they have things like 8 Mattress, for example, has sensors in the bed that can measure your sleep to some degree. I made this weird mechanism that I'm about to share with the public. It basically just slides under your bed and it holds the phone. And we access the phone's accelerometer, the motion sensor of the phone, and we can pick up on these micro motions of the mattress and tell when you get out of bed, when you roll over, and we're also measuring sound in the room. We can tell when you're snoring and breathing and your breathing rate and stuff like this. So it's turning the phone into a smart bed so it can actually measure your sleep.
So does it eventually say you should see a doctor?
So we have yes. So we can't diagnose sleep apnea, but there's changes in your heart rate variability that correspond to these hypopneas, these brief awakenings that are associated with sleep apnea. And when we detect a certain amount per hour, we will connect you with a doctor. And I'm just onboarding. My next step right now is I'm onboarding doctors, and we're going to have this system where you come into our software, we'll instantly categorize your issue, give you a program, and then connect you with a medical professional, essentially.
So there's been some news coverage of a device that failed. I think I'm gonna get it wrong. Was it a Philips sleep apnea breathing device? There was one
Oh,
great
right.
big,
They make a lot of them, yeah.
and there was a lawsuit, and they're doing a recall of millions of devices. What
Oh,
I
wow.
find interesting about that was that I didn't know that sleep apnea is maybe not something people talk about in polite conversation. So, like, I've had a couple of friends who've traveled with sleep apnea devices. Um, it it seems to me that you're at the very leading edge of what is an enormously big space. Um, does it feel like? Can you give us an analogy? Are you like in 10 years, will your sleep doctor be like your dentist? You go every 6 months?
Yeah, I mean, I actually see the dentist as playing a really important role in this whole thing. So part of the problem in sleep, just to give you a big view of this, is you basically have 3 types of doctors that sort of solve different problems, and they're all peddling their own thing. So if you have sleep apnea, a pulmonologist will give you a CPAP. You should probably do this. If you have you might go to your dentist, they can give you a mouth plate that can help with certain things. If you also have insomnia, you'll see a psychologist. What I see is we're going to bring together all these individuals. So maybe if you have sleep apnea, you'll actually have 3 doctors trying to solve that one problem for you. And they're sort of working together to give you the best possible care that you ought to have. And that's, I think, the future of healthcare, where these doctors, instead of being, there's no internal medicine person in making money that much in healthcare anymore. We're trying to sort of bring all the care providers together to solve real problems, basically.
So give our audience some advice. So how do you, let's assume, so in my case, I don't have an Apple Watch, I don't have a Ring, I don't have any of those devices. Like, what would make somebody think they need to start studying their sleep patterns more?
I mean, so one of the big telltale things is if you're tired during the day. And sometimes you're not aware of how tired you are during the day because you've experienced it for a long time. But around 10% of people have sleep apnea. And if they're untreated, they could like fall to sleep while they're even talking to someone in a conversation. So there's something called the Epworth Sleepiness Scale. That's a publicly available thing. And that'll evaluate if you are someone who suffers from being tired during the day. A lot of this is also just anyone who wants to optimize. So, I mean, wouldn't you want to get, if you could get just as much regenerative sleep from 7 hours as you did from 7.5, that would be ideal. And I think anyone can benefit from that. There's a lot of easy things you can do to accomplish that. I mean, the main thing is in training your circadian rhythm, basically. So as we get older, sort of our natural 24-hour rhythm can get flattened because of things like chronic stress and stuff like this. You want a healthy rhythm. And the way that you get that, usually a healthy rhythm, you'll have a peak alertness around 2 hours after you wake up, a dip during siesta time, another peak alertness before dinner, and then you'll gradually decrease alertness until it's at an all-time low at around 3 a.m. That's your circadian rhythm. Generally, it shifts from morning people or evening people. The more regular you are with the timing of sunshine, meals, exercise, when you go to bed, when you wake up, the more entrenched your circadian rhythm will be. That's giving your body these cues for when it should be awake and asleep. That literally changes your DNA through chronobiology. And so that will make you have deeper sleep.
So Matt is asking, is there some sense of how insurance companies are approaching coverage for sleep health, software, devices?
Yeah. So, I mean, recently, I'm looking into this very closely. So recently there's software as a medical device. There's been changes to that. So you can do that. And they have these new codes for remote patient monitoring, basically. The problem is if you're doing something like insomnia, the clinician doesn't make any more money when they're billing it out because it's a psychologist. So I'm pretty sure the psychologist would have to work with an MD in order to bill out for these new remote patient monitoring codes and potentially get paid more. But generally, the way that doctors get paid in this right now is to go into a sleep lab and get diagnosed and treat them and diagnose them for sleep apnea. And there's a ton of competitors that do remote diagnosis on that already.
So be optimistic for a moment. Get in a magic time machine and go forward 10 years. Where is your technology? Where are you professionally? And where is the space? Like I know there's drama and complicated and insurance and codes, but I want to be a little bit more optimistic for a moment. Like, we all are healthier, we feel better, we understand, like give us the good news version, and then I'll ask you for the bad news version.
Yeah, I mean, the good news is that you'll be able to easily get diagnosed and treated for something like sleep apnea or insomnia, and that we're creating something called big data cognitive behavioral therapy, which is, I hope, going to be the new gold standard for therapy. So, as a psychologist, I was always struck by how sometimes we're not so clear when what we're doing is working or not. And so we're going to actually expose whether the treatment works more clearly to the provider and to the patient. And then we're going to touch people. I think that the clinician is going to be able to touch people more intimately in their home environment. And what I mean by that is literally creating routines and wake up experiences where your home adjusts sound, light, and temperature based on a prescription that, as a doctor, I can seamlessly give to you. And I could adjust it in my weekly sessions with you. So we're thinking about, a lot of competitors in the space try to replace the doctor. We're trying to augment the doctor and show that when we use technology, you can give your patient better outcomes than when you just stick to your standard treatment.
Dan, that was a fantastic vision into your world, and appreciate the advice, Dr. Snooze. And we'll be looking for you at the next cocktail party so we can corner you and ask you more personal questions that we didn't want to ask in public.
Sounds great. Thanks for having me.
Thanks, Dan.
Okay.